All right, why don't we talk about the challenges and the benefits that arise in mechanical design when using an AI-enabled controller like machine motion AI?
I think there's two school of thought. You can think of using AI to augment the performance. I think we're in the school of thought of using AI to increase simplicity, and that's really the journey we're onto. AI is abstracting a lot of the work that needs to take place to make those system work, right? It's you no longer need to program robot in a very prescriptive fashion. You no longer need to learn all those very tricky programming mode for robots. You work at one level of abstraction higher. You can define mission instead, and that will make robotics accessible to more people. You know, we already saw in that journey from industrial robot to collaborative robot how improved UI UX user interface have increased adoption. I think AI will bring us one big milestone forward by even abstracting the need to learn all the robotics function and instead simply, either using demonstration learning or, teach by doing to program fairly complex motion without the need to learn robotic programming.
What about like humanoid robotics?
It's funny. There's so many people that would have very strong point of view on humanoid. I think mentioned here were in the camp that they will have a role to play. In factories. I think they might be good for certain use cases and less so for others. Um, Usually, the more production volume you have, the more fit for purpose you want your manufacturing device to be, right? So if you don't need two arm and two leg to do a certain task, I don't think manufacturers will want to pay for two arms, two leg. You want to pay for one arm or for two arms, but maybe not the legs. But in certain use cases, you will need the two arm, two leg, perhaps, and the cost of having those additional devices will be worth it. So I think we're just pragmatic. I think in all cases, this will take some time for that technology to mature and yield a real result for manufacturers compared to states of some of the existing technology that we find in industrial automation. But I think overall, humanoids are great for research. They're great for programming, advancing the state of AI and robotics. And I think manufacturers will probably be able to benefit from all the investment that we're seeing in humanoid through other form than humanoid themselves, perhaps in the form of software first and foremost.
And
Okay.
to piggyback off what Etienne said, one of our most popular configured items that we sell is a robot pedestal with just wheels on it, and people are wheeling robots already to fixed positions to do tasks. And just like Etienne said, if you don't need two legs, people aren't going to buy two legs. And I think that a lot of people really just needs a fixed operator to do a task. And so I think that there's going to be a lot of fixed operational tasks like there already are, but maybe more, and they'll be programmed more easily.
We were talking about how machine motion uses cellular connectivity to improve remote monitoring or control, and what implications might this have for maintenance and mechanical diagnostics?
There's so many reasons why you want machine to be connected, and I'll name a few. And even though the world of manufacturing is, maybe a couple of years behind, perhaps what we see in the world of enterprise software, I think the gap will be bridged to the same extent. Today, in fact, it's funny in enterprise, most often there's policy to make sure that you're no longer allowed to operate on-premise software because it's hard to control the quality of backup and so on. If you rewind back just 10 years ago, it was the opposite rules that exist within the governance of companies. So I'm assuming that trend will also percolate in the world of manufacturing. But a connected machine will become a de facto more safe machine because you have, whether you're using Wi-Fi over the connectivity, that means the machine is software upgraded. That means any vulnerabilities or cybersecurity risk are, patched as the software evolve, right? And in a world of AI where newer foundational model needs to be run on the edge, you're going to need upgrade. And if you need upgrade, you need to make sure you maintain the cybersecurity of those equipment as well. Now, you have choice to connect machine. Some company prefer to use their own Wi-Fi. Some company prefer not to use their own Wi-Fi and prefer the machine to be connected straight to a cellular network to not create any entry point. We offer both option and let client define. Now, once the machine is connected, there's so many things we can do on top of maintenance and on top of monitoring. First and foremost is something that is, one of our, a product that has a lot of adoption is what I call remote support, right? So you think about the operator is on the second shift. There's a problem on the machine. Maybe there's a forklift operator that hit the sensor, or something of the sort that could happen. A click of a button, you're connected to a customer success agent on our side with camera, so we can see the operator, we can see the machine, we have access to all the vitals of that machine, and more importantly, we have the same digital twin on our side, so we can understand exactly what's wrong, what's the next part, ship it on the spot, so it's there next day. So that remote support feature is just an insurance that the machine will keep running. Now, we've touched on use cases such as monitoring of those machines, monitoring the vitals, meaning is the machine operating at the right temperature? Is it consuming the right current? But also the performance of the application. Am I having the right OEE, the right cycle time, the right part per minute? And both are necessary to be monitored to make sure the life of the equipment. And then once you have that data, when you're pulling that data, obviously you can start to go in the world of predictive maintenance and keeping those incumbent running as you see deviation for the normal behavior of the equipment.
What if something goes offline? I know you talked about backup and all that, but what if it goes offline? What if the cellular towers go down? Whatever the case may be. However you're connected, if the Wi-Fi needs to be rebooted,
Yeah.
how does that affect that line?
Yeah, no, that's a very good question. And I think today most people have shifted to very reliable architecture where machine can operate on a standalone fashion without need of connectivities. And if the connectivity is put off for a little while for maintenance reason and so on, and comes back, the syncing continue afterwards. So so we have one of those architectures, probably the same architecture you would have in your Tesla, for example. But so the machine don't need to be connected for operate, but there's just so much extra value you get by connecting those equipment.
As machine builders look to scale or upgrade systems, how does the design of Machine Motion AI support the modularity and easy mechanical adaptation? I know we talked a little bit about that, but if we could look at that from the future-ready features and scalability aspect.
Say, as a machine designer today, you want to bet on the ecosystem that will give you the most use case possible with the least pain possible, right? So Vention today, I think the library is around 3,000 parts. We have the privilege to work with 3 great robot brands, Fennec, Universal Robot, and ABB. I think our component marketplace is ever expanding. I think it's hundreds and hundreds of products from our partners that are now available and compatible with all the other SKUs. So you know that when you work in that environment, you're going to get a lot of ease of use and and speed. So I think this is what I would spend a lot of time is to what extent is the architecture and the ecosystem mature, advanced, and I think this is something Vention is very uniquely positioned to provide to machine builder.
So let's talk about the user experience for our engineers. So from a mechanical engineer's perspective, how intuitive is the interface and programming environment for Machine Motion AI when creating or adjusting machine motion profiles?
So what you see here is the interface of Machine Builder, as you see on the left side, you have this library of Lego parts, 3,000 of them, and you'll see here in the people just drag and drop those parts. You no longer need to design geometry from scratch, right? You work with that library, and you'll see as the designer here is adding parts at various places, you'll see the price being adjusted in real time, and the bill of material on the right side being constructed at the same time, and that will go up to all the fasteners that you need, all the wire that you need. It's very, very complete. Now, there's a little very, very cool feature you'll see in a second. When users approach certain part, you'll see in a second, see this little magic ball appearing, right? And when you click on those magic ball, the right part goes straight where it's supposed to go. You don't no longer need to orient the part and place all those degrees of freedom as you would in a traditional CAD, right? So we call that this feature Magic At. It's an AI-driven feature, so you no longer need to search this vast library of parts. You simply mouse over a given mechanical use cases and will recommend the part that is best positioned to go to a certain place. So brings, again, a lot of simplicity. And now by the time you're done designing, you have a price, you have a bill of materials, and you can decide to either order that equipment or to simply move to the next step, which is the programming step. So here I'm going to show you different use cases where it's a simple robot cells with a conveyor and an ABB robot arm. And in the exact same environment, I shift to a programming mode where I can add those various instructions. I can even see which IO is being used, and so you can go pretty deep at programming your entire robot cell. And that digital twin, if I can sum the digital twin as the mechanical design and the programming, actually translate one-to-one with the physical twin, because that simulation is the exact same that's going to run on machine motion AI when you're going to deploy that equipment. Which brings me perhaps to my last little demo here. So in a world where your machine motion AI is connected, whether it's through Wi-Fi or through cellular, you always have the ability to push your latest digital twin back to the physical twin. So that's what we'll see here. The user selects what you want to deploy, its configuration, a couple of software, and he's simply going to deploy, and that simulation that we just saw will run on the machine instead of running on the cloud. And the operator now can then take the pendant, the teach pendant, and operate the machine from there in the factory floor. So it's a very united workflow that is pretty simplistic to learn. I think, as Sarah mentioned at the beginning of our discussion, Sharon, we're starting with machine builder courses so people can learn how to design those machines, and we're confident it's going to bring more people around the table using Vention as a platform.
Well, thank you, Etienne and Sarah, for joining us today. And thank you for joining us. And until next time, I'm Sharon Spielman with Machine Design. Stay curious.